So thanks, everyone. So yeah, my name's Damian. I'll tell you a little bit more about myself in a sec. But this talk, typing is not the bottleneck, this phrase popped into my head a couple of years ago in a meeting. Somebody in this room was also possibly in the same meeting. And it was at a big company in a big sort of workshop session about something, and people saying, well, these are what we want from this system. And the head of finance got up and said, I have a requirement for this system, that the developers write the code so it's reusable. My first instinct was to tell her, you worry about adding up the numbers and let the code to me, but I didn't. But yeah, this thought that the biggest problem was typing. So my name's Damian. I do know a few people in this room. I currently call myself a consultant CTO. I've done a bunch of consulting, been CTO of a couple of companies. I was CTO of Octopus for a while in the early days. And now I'm sort of freelance, independent, probably pretty similar to a lot of the stuff Simon does. I'm sort of acting as a CTO for a bunch of small companies that don't have one. Also still actively write code and do a lot of software architecture. Your comment about we have this legacy system, so we're going to turn it into 20 microservices. What could possibly go wrong? Yeah, love it. I'm sure everyone in this room sort of worked on a project that they would consider a challenge, hard, awkward. We drink to forget it. We've all had that project, right? And usually those things it was that thing that bit us at the end, right? That was the challenging part of that project was that final requirement in the last month. It was we put it in prod and it fell over in a screaming heap. Those sorts of things, those are really unknown things that hit us at the end. Yes, no, yes. But rarely did we look back at those projects and go, you know what? The problem with that was we didn't have enough typists. Rarely the problem. So today, I basically want to tell you a couple of stories and talk about a couple of things that I've seen in my travels. The first one is about a bias for action, which is given the choice of doing something or sitting around and talking about it and pondering about it and whiteboarding about it for several weeks. Or worse still, we're blocked. But we should do something. Do something, do anything, do something small though. So basically I want to talk about doing more things and worry less about them. I want to talk about how you can learn by doing small things, even if they're wrong, even if you throw them away. We can learn from that. And we're going to learn more by doing a small thing that might be wrong and we throw it away than we can learn from weeks and weeks and weeks of agonizing over the perfect solution. Because there isn't a perfect solution, right? You're always going to be wrong at some point. But if you're going to be wrong anyway, why skip a bunch of opportunities to learn along the way? Because we want a learning culture. We want to have a culture where we can optimize for learning, because that's where we're going to have the most success in companies and in teams and in our projects. So a key theme that keeps popping up for me was a story that I read years ago about a pottery class. I don't know if people have heard this story about the pottery class. Few nods. So it was an anecdote, and I've tracked it back to a book called Art and Fear by David Bales and Ted Orland. And there's a story about a course on pottery. And as a bit of an experiment, the instructors at the beginning of the semester divided the class into two groups. And they said, Group A, you're going to be judged on one pot. So you've got all semester to make the perfect pot, and I'm going to judge you on the quality of this one pot. They said to the second half of the group, to the second group, you are going to be judged on the quantity of pots you make. Literally, at the end of the semester, we're going to bring all the stuff in, we're going to put them on the scales, and whoever has the most clay gets the top mark. And so everybody had, a preconception about how that was going to work. If we sort of plan and design and make this perfect pot, we're going to get top marks. But what actually happened was that by the end of the semester, the works that were the highest quality were produced by the ones that were optimizing for sheer volume, because they were being graded for quantity. So basically, they were just making lots and lots of pots and making terrible pots at the beginning. They were probably just dodgy lumps of clay on the wheel, but they by the end of it, they'd made so many pots that they'd got it down. So the pot that they sort of, turned in 15 minutes on the last day was of higher quality than the group that were optimizing for the perfect pot. What they had was a bunch of theories and grand designs, but something terrible because they actually hadn't had much practice in making pots. Which brings me to one of my favorite quotes, which is, good judgment is the result of experience, and experience is the result of bad judgment. I've lived that. Another great way of saying this, a slightly more modern example, is Trombone Shorty. Anyone heard of Trombone Shorty? No, one. I did this talk a few weeks ago and somebody came up with, I love that reference, I've lived in New Orleans all my life. So a New Orleans jazz performer named Trombone Shorty who has a song, he said, nobody never learnt nothing from no good time. So we learn from our mistakes. Now the thing is that I'm not advocating that everybody goes around trying to create disasters. Not saying that. That's a bad thing. What I'm saying is that we can eliminate a lot of risk by doing small things and making those small mistakes really, really early in the process, because we're going to be wrong about stuff. And so if you acknowledge that you're going to get stuff wrong, it's probably to be better to be wrong really, really early. So I'm going to talk about some stuff that probably will seem at odds with what Simon talked about this morning, but also Simon talked a lot about putting some code out and spiking out and do some proof of concepts and stuff to actually figure out. So I don't think we're actually at odds, because you are going to get stuff wrong. So it's better to look for ways to find that out. The thing is that if we punish people for being wrong, then they're going to optimize their daily choices to never make them. Yeah? So, if you're in a situation, you go, I think I've got a solution to that, but there's a risk attached to it. And then my choice is, well, I can take this risk, learn something, but if I get it wrong, I'm going to get beaten up for it, then I'm not going to do it, and I'm just going to sit there. So, if you've sort of created that environment as a leader, where people are going to get punished for making mistakes, then you're never going to make them, and you sort of miss out all those opportunities to learn. So once you've killed somebody's ability to learn, then you minimise their job satisfaction entirely. And then, why bother coming to work? And so if you're a manager or a leader and you've created an environment where, people don't want to come to work and don't want to sort of bring their A game, then all of a sudden you've got a team who are basically just sitting there costing you money and not doing anything as a result of the culture that you've created because you've disincentivized creativity. So a couple of other little stories that I've seen in my travels. So this is the tale of two agiles. So a little bit, and this is a little bit of history that probably most people here know. Who knows about this paper? Not many. That's awesome. So there's a paper written by Dr. Winston Royce called Managing the Development of Large Software Systems. And it's a very famous paper because it was the first documentation of this, the waterfall. And in this, Dr. Royce sort of talked about this thing where we gather some requirements and we have some assumptions and we do a design, we implement it, and then we go, did it work? We test it, and then we put it into operations and we maintain it. And unfortunately, people read that page and went, fantastic, let's stamp some certifications on it and run with it, which was a terrible, terrible thing, because had they read the next page in this paper, they would have learnt that this is a terrible thing to do. Because if your assumptions were wrong at the beginning, then, and your project is run like this, then you only ever have one chance to figure out if your assumptions were right or not. And so what you should do is be running this process continually, in this iterative process, so you have an assumption, you figure out how you're going to test it, you figure out how you're going to build it, and then see if it was right and be able to repeat that along, So, this isn't a new concept. This is sort of largely what we consider to be agile. One of the criticisms that you sometimes used to hear, not so much anymore, about agile is, hey, this is all well and good for building little websites, but you would never run a space program like this. So the thing about Dr. Winston Royce's paper is he was working for Lockheed, literally writing mission control systems for the space program in 1970. None of this is new. But unfortunately, these concepts have been turned very, very bad. And possibly unfairly, Scrum's a lot to blame for this, because Scrum, Mike used one of my favourite phrases, which is you turn your project into a series of 2-week death marches. So, we've got Scrum, and we're right, and we're going to take our 18-month project and just chop it up into 2-week things and plan it all ahead. And we still have fixed time and fixed scope and fixed everything else, but we're going to stand up every day in the morning and call it agile. And we do that because we can't transform the business. Who has the business? Few people still have the business. So yes, we have this sort of series of short death marches. And so then you see a whole bunch of horrible things happen, like the requirement sprint, where the BAs are working one ahead to quickly try to write given when thens for all the stories before you get them into the development sprint. And you have horribly vague architecture documents, which are like, the business logic sits here, because no one's actually got time to figure out what the business logic is. We'll figure that out when the BAs talk to the business and write the logic down. So we end up with this just horrible approximation of software development where everyone's writing just enough code, documentation, whatever else to not get fired. And it's horrible. So we've all been there, right? Everyone's seen that version of Agile. So in my consulting career, I was lucky enough to see a project that looked a lot like that. And it was a company replacing their legacy system. We were just going to build it over here, the same as that, but better. Famous last words, right? And they were 5 years into a 2-year project to replace this legacy system. And it was pretty bad, and they were standing up every morning and called for reinforcement. So a bunch of colleagues and I went into this company, and we did some architecture spiking and figured out that actually replacing that with this thing over there wasn't going to be the way to get some traction. So we were going to start to break off some functionality into some services and modularize it so we could at least get some runs on the board. And so what happened was one of our consultants went up to the business and said, hey, look, we're new here, we're working on this system for you. Can you tell us what this thing needs to do for you? And had their head bitten off entirely. Completely bitten off. Like, we've told IT the requirements 5 times now, they've documented it all, we're not going to talk to you, go away. Which is, predictable. You've seen this, haven't you? So our team went, okay, look, our bad, we're stupid, we're new here. Can you just tell us, so we know where to look, what does it do? It's like, well, simple. We just need to pull this data and this data and this data, and we look at the thing, we make a decision on this thing, and we press the button to approve or deny. Okay, cool. And they went away and built just that. They came back the next day and went, hey, what about this? No, you idiot, that's not going to work because we need this. Okay, cool. Came back the next day. What about this? Yeah, you kind of got it, but look, it needs this and this and this. Oh, okay, cool. The next day, came back. Yeah, no, that works, except on Tuesdays when this rule kicks in. Oh, okay, cool. Within a week or two, we'd actually built the system. So here's, the business has been waiting 5 years for the system, and, within a week or two of actually coming back and sort of having an assumption and validating that we had a working system for them, and some architecture to support that. And that was a really good example of actually being agile and getting, within that 2 weeks, this system was actually in production and being used. And it was one of those really good examples of, look, rather than kind of figuring out, get all the requirements perfect and signed off till we're done, let's just go and we're going to make a bunch of mistakes, and those mistakes involved in people getting their head bitten off, but we were used to that, that's fine. But it was a really interesting example of just doing really small things and learning from them really, really, really quickly in a fairly hostile environment. So one of the things that you need to be able to do this, and I think you mentioned the tracer pattern, tracer bullet development. Who's heard of that? Yeah. So I like to call it get hello world in production. Figure out, okay, we're going to build a system over here. Let's just get our blank page with hello on it all the way through to the environment. And once you've got that, then you can start to iterate. Then you can go to the customer and say, hey, what does this need to do? Yeah, and we can go and we can do that and we can bring it back to them. Not, hey, let's batch this up, so we're going to take 6 months worth of requirements, write them down again, and then go away and hopefully deliver on it. It's actually like get something really basic to production and then work with the customers to iterate on it really, really quickly. Do lots of small things as you go. The lovely thing about that is you build only what's needed. So if you're into lean, you're introducing less waste into the system because you're not building stuff that you don't need. You're actually building what you know you need because you're getting screamed at if it's not there. So it's a lot less waste. Works in big companies, works really, really well in startups. Lean startup is kind of all about this sort of stuff. Get something small out there and then validate your assumptions by A/B testing. That's worked really well for me. I was, in a small startup last year, and I could have spent 6 months kind of figuring out exactly, but I went, you know what, I'm just going to ship something out, solve a problem today, and then iterate really, really quickly as I went. And it's a great way to learn new infrastructure and new environments. It's a great way, if you find yourself in this situation, to learn a new domain. Nothing validates your knowledge of a domain faster than getting it wrong. At the same time, you can deliver value, within that business, and actually be dealing with customers, be actually like solving real things. A lovely example of this is the Facebook Messenger team when they launched that. They had an issue that a lot of big companies do, which is around load testing. How does Facebook load test? They don't have their performance environment where they can put, an entire replica of Facebook's infrastructure, in their B data center and load test stuff. So what they did was put some code into every Facebook page to actually call back to the Messenger service and make some calls on it. So they were able to scale up and test out and performance tune that entire infrastructure as they went. So by the time people saw Facebook Messenger in their browser, it had been running in production and being hit with, the load of that every single day. So really easy to kill that kind of, as a leader, really super easy to be able to kill that sort of initiative. When you start asking questions like, well, who chose that? Who made that bad decision? Whose fault was that downtime? So probably some of the stuff you've seen around error budgets, it sort of stops becoming, or whose fault was that? It's like, how do we fix this? Like, we've got a metric for it. How do we fix it rather than whose fault is it? Whose company does does root cause analysis where they ask the 5 who's? They're the best meetings. So if you are in a team, where that's the culture that has been created, you're quickly going to say, well, if I do a new thing and there's downtime and I'm at the end of the 5 who's and I can't blame anyone else, then I lose. So I'm going to leave, which means, as a company, you're not going to have people with initiative, which means you're going to be really boring tech, which means you can't hire anymore because everybody gets stagnant. We've all worked with those people who just stopped learning. Like, why are you even here? No one wants to work in that. So, as a leader, if you sort of created that 5 who's type environment, then everyone's going to get stagnant. You're going to really struggle to bring in world-class people. Obviously, to do this, you need the engineering and the quality. You can't. If you're sort of starting to iterate like this, you can't be throwing crap up against the wall every day. And you also can't be manually copying files onto the production server. Obviously, there's an investment in, CI/CD, release tooling, release engineering, suites of tests, TDD, whatever it is you do. You need that engineering, foundation in there to make it happen. But once you've got that sort of iterations in place and the engineering to make it fast and safe, then you can start to do stuff. And then you can start to say, you can start to really call Yagni on stuff like, what do we need today? What can we get out there that we can learn from? What can we ship today that will give us some value and that we can learn from? And not do the stuff that you don't need to do now. Because when you're working in this, you can avoid this. This is like the best metaphor for enterprise software ever. There are so many just-in-case features in this thing and what-ifs. yeah, every bit of enterprise software. But when this is your software, you end up with this stuff that has a million configuration switches. Deploying and managing is terrible because you've got a config file that's that long. You've got a million menu items and checkboxes and stuff because somebody sat down and wrote down all the requirements and went, right, we need it to do all of these things rather than shipping and learning and actually building the things that we needed to build. One of the other sort of nice things is stuff becomes a lot easier to operate. Again, I was talking about configuration switches. The developer experience when you are able to move in these really small batches and learn from them is you end up not making things overly configurable from a development point of view. This stands for just something, hard code it, which is great because often see people work on a system and they'll go, well, this might need to change, and 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 all of a sudden they're optimizing for all these changes that might not ever actually happen. Whereas if you ship and then ship again and then ship again, you'll get to a point where actually in this environment this needs to point over there and this needs to do this. And you can start to build those configuration features in as you need it, because every configuration switch essentially is a feature. And something I've seen is that the developer experience of a code base is a really good sign of a healthy company. If you can walk into a new code base, clone the repo, look at a README, run a script, and then be running it 5 minutes later, that's generally a super healthy company and a super healthy dev team. And I think you alluded to this as well. If you've got, it takes 6 months to get a working developer environment because there's a million configuration switches, that's generally a bad sign. So again, sunk cost fallacy. So I think Mike mentioned this as well. You can tell we've worked in the same places. This idea that once you've spent money on some software that you have to keep it, sort of leads to some really bad thinking. Because it's, okay, well, we only want to be able to write the code once. So what do we need to do so that we never actually have to touch this code again? Can lead to some really, really bad decisions and some really bad thinking, rather than just, hey, look, code is this thing, like once it's out there, we can replace it and that's okay. Gives us the ability to innovate a lot faster and build smarter teams. And I've seen this, an example of a team looking at, well, do we go with this approach or this approach? And it's like, well, that one we think will ultimately be better, but this one we can get running tomorrow and we'll actually learn if the general concept is going to work. And I saw this team, there was a whole bunch of arguments about, yeah, but that's not going to work eventually. And they were right. But thankfully the team went, well, actually, we can ship this tomorrow. And they did ship it tomorrow. And they found out why it wasn't going to work. But they learnt that, the next day rather than learning it in 6 months' time when they hit production. And so when it came time to actually, okay, we've now hit the limits of this, we know where it's going to fail, we know what we need to do over here, it only took one developer an afternoon to completely swap out that library and that approach and change it. Whereas otherwise they'd have sat there, whiteboarding for weeks and weeks at a time to sort of come up with something that will hit them with every possible failure scenario, most of which wouldn't have been applicable. So by actually just picking the option that let them ship tomorrow and get some feedback about the environment they were working in, led them to a much faster solution, which had they been so concerned about, well, we might have to throw away some code, they never would have gotten there. So, because throwing away the code, like I said, importing it took an afternoon. And you see this all the time, and you see this when you go into companies and they've got a homegrown framework. Rather than because they weren't able to get to production quickly, they weren't able to iterate super quickly, they'll sit there and kind of imagine every possible business rule scenario. They come up with this all singing, all dancing framework that it's okay once the requirements have been signed off, we'll just plug them in and this thing will work. And of course it never does, right? I've never seen that one work. Because they prematurely make things generic rather than just releasing something, building on it and building on it and building on it. And then, eventually you might build that, extract that framework from something that's working, but where people sort of start with the framework because that's their only shot at it, it tends to go horribly, horribly wrong. So instead, if you can release some tiny bit of code that just does what you know it needs to do today, but it's well tested, it's well engineered, and you can change it, then you can refactor it as needed. And by that, I don't mean, okay, in April, we're going to spend 2 weeks and have a refactoring sprint. So that's bad. But do this a lot in small chunks. One of my favorite definitions of refactoring was Neil Ford from ThoughtWorks. Talked about changing code to match the new understanding of our domain. So you've got some code out there, you've learned something from it, either the domain has changed or you've got a new requirement or you have a new understanding. So, be able to quickly change that code to get there. Obviously, you need a high trust culture. So the companies that have done this really will have this baked into their DNA. So a company like Zapier, on day one, you get told we've got this bias for action, radical transparency, because you can't afford to be blocked in a distributed company across every time zone in the world. You need to be able to act. And if you get it wrong, that's on the company for not being transparent enough about the environment. As opposed to, the big enterprise companies where you have a product manager that drip feeds stuff down to, BAs who drip feed it down to dev leads who drip feed it down to the developers, and architecture teams who are very, very prescriptive because our developers aren't very good. And then if people actually try to break out of that and actually get something done, then they get punished for it for not being team players. And in those sorts of environments, I've seen a very, very senior manager go, yes, but when will our team be transformed? Actually had that said to me. All right, some quick takeaways because I've got the wind up. Make a lot of pots. Ship early, ship often. Don't be afraid to get it wrong. Because shipping something today will help you learn something. It has some value, even if it's the wrong thing, you will learn why. Remember the sunk cost fallacy. Don't be afraid to throw away ideas that weren't good or don't work because you've gotten value one way or another. Either it worked and now it doesn't work because the environment changed or there's some new requirements or whatever. You've already gotten some value out of that because it might have, converted a customer, you might have earned some revenue, or it might have just been knowledge. If it was you put it out there and actually it's not going to work, well, at least you know a bunch more about your environment that you didn't before. So by the time you've got code running out there, it's paid for itself, it's had value, and replacing it is just typing. That's never we're all super fast typists if we're writing code every day. Don't punish failure. So this is, as technical leaders, the thing that got shipped had some value. If it doesn't do today what it needs to do today or tomorrow, that's okay. Don't punish people for failures because, we've learnt from it. Invest in the engineering so that you can move fast. You can't do this if you are being sloppy about how you build it. Our jobs as leaders is to enable these environments because if we don't, then we're going to have people that work with us that we don't want around us. We're going to have those people that have stopped learning, they've stopped being creative, and that's going to slow us all down. Invest in our people because they'll make you great. And ultimately, we do this because we can make money from it. If anyone's read Accelerate, the science of lean software and DevOps, there's a whole bunch of studies into the companies that have brought these sorts of models in and have built these high trust cultures and built in the engineering. The results speak for themselves. If anyone hasn't read Accelerate, do recommend that because the money very, very much follows the practices. So with that, thank you very much.
Fantastic.